Welcome everyone. In this video, we will solve a GATE 2013 question which is based on the calculation of maximum and minimum output voltage, that is our Vout, in a double diode Clipper circuit with a additional DC supply in it. So the question is a voltage signal, that is our 10 sin omega t, is applied to a circuit shown here. We have to find the maximum and minimum output voltage, V output maximum and V output minimum. Okay, so we have to find the V output. I am writing maximum, is a max, and V output minimum. Okay, so this one is two diode based problem and two additional supply is there. So to solve such a question, we have to break it in a individual diode based problem. So what we are doing, I am just drawing the same diagram here. Okay, so I am putting this diagram here. Okay, so now in one situation, what we can say, if we remove this diode, okay, this diode, so this one become a single diode problem with V output 1, and we are saying this one is our part 1, part 1, when we are choosing only D1 diode. Okay, in the second page, what we are doing, in the second phase, okay, once again, I need some space. In the second phase, what we are doing, we are just removing this diode D1, okay, and we are saying this one is our V output. This one is the technique. If more than one or two diode or three diodes are there, we have to make it individual. Okay, then try to find the V output 1, V output 2. So this one we are saying part 2 part with diode D2, diode D2. Okay, so in such situation, if we find V output 1 and V output 2, okay, in both the situation, and what we have to do, we have to take the common response, common response, which will be the output, final, which will be the final output for the clipper circuit. For the basically this one is a clipper circuit. Okay, so this one is the way, means we have to first find the V output 1 and V output 2. Okay, V output 1 and V output 2. Then we have to take the common response between the V output 1, V output 2, and that common response will be the final clipper output circuit. So when we are saying this kind of two part, okay, in any such circuit, just make this type of selection. Okay, so this one is our 1 volt, sorry, 10 volt, sorry, 10 kilo ohm resistance, so make it 10. Okay, now we have to solve this one. So now we can easily say this, when diode is on, this value will be how much, 4 volt. So how, so this one is a clipper circuit. So to solve such problem, we are writing step 1. The step 1, first we have to find the transition voltage. First we have to find the transition voltage. Now I am solving this diode problem. Okay, clear? I am just making a line. Okay, ever in that side we will solve this one and this one, then we will combine. Okay, so transition voltage when diode D1 on, okay, and the ID1 is almost zero. Diode current, transition voltage when diode on and ID1 0. So we can say in this circuit we can write like id is more or less 0 and this one is sorted. Okay, so the value of the transition voltage can be written as, I am writing directly v in, okay, plus v in, we can write plus v in minus 4 volt equals to 0. So v in equals to 4 volt. So this one is the transition voltage. So what it means, the meaning of transition voltage is that when we are giving a sinusoidal signal t, and this one is b in, and this one is 10 sin omega t, so this will be 10 and this one is minus 10. Okay, so then v in equals to 4 volt, v in equals to 4 volt, a line here, a line parallel to the time axis, simple. Okay, now this line will decide diode is on or off. So when V in is above 4 volt, diode is on, D1 on, and below this line, D1 off. Means suppose above this line, V in equals 10 sin omega t. Now I am saying this one is 6 volt, so this one is more positive than this one. So this one will be on. So D1 will be on above this one. So when D1 is on, when D1 on, okay, so when D1 is on, the output value will be finded from this loop, say loop A. So when D1 is on, so if we apply voltage KVL in loop A, we can write simply plus V out 1 minus 4 equals to 0. So V output 1 equals to 4 volt when diode on. Okay, so diode on, so the value diode is on above this one. So this one is the output response when diode on. Okay, for this, then this will be 4 volt. Okay, and when D2 is off, when D2 is off, when D2 off, so D2 off means this one is the resistance. Okay, sorry, D1, our D1 is there, no? D1 is there. Okay, and this some supply voltage plus of minus V output 1 plus minus V in. So V output when D1 of V output 1 is same as that of V in. So the output response is V output 1 equals to V in when the diode D1 is off. So D1 is off, so below this line. So when this, so it should be same as that of input. So blue line will be the output. Okay, so from here we can say the V output value will be 1, maximum V output voltage will be 4, or better to say V output 1 is maximum is here 4 volt, but we don't know it is maximum or minimum, so just write it V output 1 4, but it is maximum here, so we can write this as a maximum. Okay, because this one will be maximum here. So here from this one, the maximum output voltage will be 4 volt. That we can easily find from this circuit. Now we have to take care of this circuit. So again, in step 1, okay, step 1, we have to find the transition voltage. So during the transition voltage, this will be sorted. Okay, and just apply KVL. Okay, say this one in loop 1. Okay, we are doing transition voltage in loop B. When doing transition voltage in loop B, the D2 is our on, and ID2 we can say will be 0 at that time transition voltage. So applying KVL we can write plus V in ID 0. So ID2 0, no need to care about this one, 0. Minus plus, so it should be plus 4 volt, and this current will be also 0 here. So it should be our V in equals to minus 4 volt. So here this minus 4 volt will decide the transition state. So for this purpose again I am just doing it. Okay, V in T and minus 4 volt, minus 4 volt. So this will be some line here, V in minus 4 volt. Now above or below this line will decide diode will be on for which, for the sign. So when V in is above minus 4, suppose this one is minus 5, minus 3, 2 or 5 volt, or suppose any voltage, say this one is peak to peak is 10. So any voltage, say take suppose 5 volt. Okay, so when it is 5 volt, this will be the reverse bias. So above this line D2 become off, and below this one any voltage, say minus 10. So this one is more negative, so this one will be forward bias. So D2 will be on. So this kind of practice you have to do. This transition voltage, and above this voltage, when input is anything, we have to decide D2 is on or off. So now it is clearly observe that below this line when minus 10. So when it is minus 10, when it is minus 10, this is more negative. Minus 10 here is always 4. So this one is more negative, and this one is P and N. So this one will be reverse bias. Okay, sorry, forward bias. So this one will be D2 will be on. So this one is very important aspect. Okay, so now one can also observe that in this case diode, when diode is on. Okay, so now I am just making the one, this circuit. Okay, just say V in, and this one is 10 kilo ohm and T2 and 4 volt, and this one is 10 kilo ohm. Okay, now when D2 is on, D2 is on in this range, D2 is on in this range, it will give the output response, some output response. Okay, so now for the time being saying, I am saying some current will flow when D2 is on. Okay, and when D2 is on, and this value will be, say we output 2. Okay, when D2 is on, so D2 is on, and in that time we are saying it is the maximum value will be minus 10. So we can say the maximum value will be like that, minus 10 minimum, so better to say minimum. This one will be minus 10 volt. So I am saying when D2 is on, okay, the minimum or value of this one will be minus 10 volt. So this current and this current will be more or less same. So this current IT2 and this one is also IT2 will be same. So what we can observe that this resistance is there, this voltage is minus 10 volt. Okay, now basically this was sinusoidal, but in our question we have to find the maximum and minimum. So I am saying this one is minus 10 volt. Okay, minus 10 volt, why? Because this one is the region, this one is the region where the D2 is on. So when D2 is on, it will give some output voltage. So this one is 10 kilo ohm. Okay, and we are saying this one is V output 2. Okay, we output 2. Clear? And then after this one is on, so make it sorted. Okay, and this one will be the 10 kilo ohm. Okay, so I am saying this current ID2 and ID2 will be same. So ID2 here, ID2 here, if this one is some resistance, a minus 10 volt, and this one is 10k, and we are put to, and I am saying this one is ID2, so we can write minus 10 volt lower potential, sorry, higher potential. Now we can say this one minus 10 volt minus V output 2 by 10k ID2. Now from this one also we can find the value of ID2 by writing KVL equation with this one. Say KVL at 1. So what can write? V output 2, and this way minus plus. So it should be plus minus ID2 into 10k equals to 0. Okay. So from here we can also write ID2 equals to V output 2 plus 4 by 10k. Simple calculation is there. Okay, so say this was equation number 1 and equation number 2. So now equation 1 and 2 are same. So we can write 10 minus V output 2 by 10k equals to V output 2 plus 4 by 10k. ID2 same. So from here we can write 10 minus V output 2 equals to V output 2 plus 4. Now from here we can write this one here. Twice V output 2, twice V output 2, then 10 minus 4. Is it okay? 10 minus 4. V output 2, V output 2 minus 10 minus 4. Then it will be 6 something. Okay, I think something I have missed out. Okay, okay, sorry. Miss, here we have to put minus sign. Okay, because I know the answer. That's why this one is minus 10. Okay, we have forget the sign here, so it should be minus 10. Okay, so this one is a mistake here. Yeah. So it should be minus 10 equals to twice V output 2 plus 4. So twice V output 2 equals to minus 14. Okay, so V output 2 equals to minus 7 volt. So V output 2 is minus 7 volt. So we can say the V output 2 is the minimum value is our minus 7 volt. So the maximum value V output 1 maximum when due to diode D1 will be 4 volt, and V output 2 goes to minus 7 volt for D2. This is maximum minimum value. So, so actually there was a mistake by me on that time. So it should be minus 10. Minus 10 minus V output by 10k. V output 2 plus 4 by 10k. Or you can solve by your convenience. So 4 volt will be the maximum and minus 7 volt will be the minimum for this question. So 4 volt maximum and minus 7. So I think D will be the correct answer for this problem. So first try to break this one as a two diode problem, and then we have to find the output response. So we have to find the maximum minimum value. So here the minimum one, because both the current will be same. So here I had made a mistake, so minus 10, and we output minus 7. So this one is the answer. Okay. So this one is all about this question. So thank you for watching this video.